far out in the long dark between the stars where no morning has ever broken, there hangs a sphere of perfect shadow, and along its outermost edge, too faint for any eye to catch, a thread of warmth is rising. Not fire, not flame, just the barest shimmer of light leaking away from the rim of a thing that was once thought to keep everything and give nothing back. A black hole, the darkest object the universe knows how to make, is glowing, ever so slightly, the way a stone that has lain in the sun all afternoon goes on giving up its heat long into the cool of the evening. The glow is unimaginably faint, colder than the empty space around it, a whisper of radiance feathering off into the night across millions of years. And in that whisper lives one of the loveliest ideas in all of physics, the discovery that nothing is ever quite as final as it seems, that even the deepest well in creation is slowly, tenderly emptying itself back into the light. That is where the night will rest with you now, on the warm and shadowed rim of a black hole as it dreams its long way toward dawn. There is nothing here for you to hold on to, nothing you need to keep until morning. The ideas that come to you now ask for no effort at all. Let them arrive the way that faint horizon glow arrives, having taken longer to cross the dark than your whole life will last, asking nothing of you in return. A few of them may settle somewhere beneath your thoughts and stay there. Most will simply pass on through, the way light slips across the ceiling of a sleeping room and wakes no one and is beautiful all the same. You do not need to understand any of it. Let the breath grow long. Let the shoulders come down from wherever the day has held them. You're only here to rest beside a glow so faint it took the greatest minds a century to notice it, and to let its slow, untroubled warmth carry you down towards sleep. So begin where the wonder begins, at the very surface of the shadow, where the impossible glow first appears. For a long time the words seemed simple and certain. A black hole was the one place in the universe from which nothing could escape. Not a spark, not a sound, not the faintest grain of light. Gravity there grew so steep that to climb out you would need to outrun light itself, and nothing outruns light. So the name fit perfectly, a hole that was truly black, an absence so complete it swallowed even the idea of brightness. For decades this was simply what everyone knew, and then a young physicist sat down with the mathematics of the very small, the rules that govern the smallest flickers of energy, and carried them right up to the edge of one of these dark spheres, and found something no one had expected. The blackness was not perfect after all. The hole was warm. The man who found it was named Stephen Hawking, and the year was 1974. He had not set out to overturn anything. He had simply been asking what happens when the strange laws of the quantum world, the physics of particles and probabilities, are allowed to play out right at the boundary of a black hole, in that thin shell of space where gravity becomes overwhelming. The answer that came back surprised even him. The mathematics insisted that a black hole could not be perfectly black, that it must shine very faintly, with a steady warmth all its own. When he first wrote it down, he half suspected he had made some error, that such a thing could not be right. But the equations held. The darkest objects in the cosmos were faintly luminous, each one breathing out a soft tide of radiation into the night. The paper he wrote carried a startling title, more like a question than a claim, asking whether black holes might explode. To anyone reading it in a quiet library, the words seemed to belong to some violent and distant event. Yet what it described was almost the opposite of violence, a process so slow and so faint that across the entire age of the universe it would barely register at all. A glow patient beyond all human reckoning, unfolding atom by atom over stretches of time the mind can name but never truly feel. The explosion, if it ever comes, waits at the far close of a story almost without end. For now there is only the glow, and it is the gentlest light imaginable. This faint radiance soon took a name of its own, and it is the name the night will carry with you, a phrase as soft as the thing it describes. They began to call it Hawking radiation, the slow leak of warmth from the edge of darkness, and the name has stayed ever since. It is not light in the way a star gives light, not a blaze you could ever see by, but a thermal glow, the same kind of radiance any warm object gives off simply for having a temperature at all. Your own skin shines this way, in wavelengths too long for the eye, a quiet warmth you pour endlessly into the room around you. A black hole, it turns out, does the very same thing, glowing not because it burns, but simply because, against all the old certainties, it has a warmth of its own to give. To picture where this glow is born, let the gaze settle on the edge of the sphere, the boundary that scientists call the event horizon. It is not a wall, not a surface you could ever touch, but a line drawn in pure geometry, the place beyond which the inward pull becomes inescapable. Outside it, light can still struggle free, cross it, and every path leads only deeper in. The horizon is perfectly smooth and perfectly silent, a frontier with no fence and no gate, marking only where the going out becomes a going in. And it is precisely here, in the razor-thin skin of space hugging this invisible line, that the warmth arises, conjured from the meeting of gravity and the restless flicker of the quantum world. The empty space at that edge is not truly empty, and that is the first secret of the glow. What looks like a perfect void is in fact alive with the faintest possible activity, a ceaseless trembling that physics calls the quantum vacuum. Even in the deepest nothing, far from any star or stone, energy is never perfectly still. It shivers, it fluctuates, throwing up the briefest sparks of existence and pulling them back almost before they have begun. Empty space is less like a blank page and more like the surface of a calm sea seen very close, never quite at rest, always stirred by some small unseen motion. This soft restlessness is woven into the fabric of everything, and it is from this trembling that a black hole draws its warmth. Out of that trembling, particles are forever flickering into being in matched pairs. The rules of the very small allow tiny twinned sparks of energy to appear together for the smallest sliver of a moment, two halves of a fleeting whole, born from the vacuum and meant to vanish back into it just as quickly. Almost always they do exactly that, meeting again in an instant and silently cancelling, leaving the void as smooth as before. It happens everywhere, all the time, an endless, silent fizz of appearing and disappearing that fills all of space and goes entirely unnoticed. The cosmos hums with these momentary pairs, here and gone, a froth too brief and too small to leave any mark at all. But at the edge of a black hole, this delicate game can play out differently, and that difference is the whole of the wonder. Picture such a pair flickering into being right at the horizon's lip. Most of the time, the two will find each other again and fade as they do everywhere else. Yet sometimes one slips inward across that fatal line while the other drifts free, and once parted by the horizon they can never meet to cancel. One falls forever inward, the other floats away into space as a real and lasting particle, carrying a thread of warmth out into the dark. Multiply that single chance by the unimaginable vastness of the horizon and the endless patience of time, and you have a steady, faint exhalation of light, a black hole steadily breathing radiation into the night, one stray particle at a time. Step back now and hold the strangeness of the whole picture, for it is stranger and tenderer than any story told before it. The most absolute darkness the universe can make is not, after all, a perfect end. It shines. The deepest pit in all of creation is very softly a source of light, giving back to the cosmos a thread of the warmth it was thought to have swallowed whole. There is a deep reassurance hidden in that, a sense that finality is rarely as final as it looks, that even here, at the edge of the most complete nothing, something tender and luminous still leaks out into the open. The dark is warm, the void is breathing, and the breath of it is the softest light there is. That warmth can be measured, and the number it gives is part of what makes the whole idea so peaceful to hold. Every warm thing in the universe has a temperature, a single number that says how much heat it carries, and Hawking found that a black hole is no exception. It has a temperature too, a true and definite warmth, just as a kettle or a candle or a star does. This was the revolutionary heart of it. A black hole was no longer only a trap, a mute and lightless absence. It was a warm body, a thing with a temperature you could write down, a glowing object that belonged after all to the great family of everything else that shines. The coldest, darkest thing imaginable had been handed at last a small and steady warmth of its own. Yet that warmth, for any black hole born from a dying star, is almost beyond belief in its faintness. Take a black hole as heavy as our sun, and its temperature is not a blazing thing at all, but a coldness deeper than almost anything in nature, a few billionths of a single degree above the lowest cold there is. Absolute zero, the floor of all temperature, the point where even the trembling of atoms grows still, sits only a hair below it. The sun pours out its heat across the whole sky. A black hole of the same mass gives off a glow so cold, it makes the gap between stars feel almost warm by comparison. Its light is real, but its warmth is the faintest exhalation, a temperature you would need the finest instrument ever dreamed to even begin to feel. To set that coldness in its place, let the mind drift out to the background hum of the whole sky. Everywhere you look, in every direction, the universe glows very faintly with the leftover warmth of its own beginning, a soft bath of light called the cosmic microwave background, the cooled down echo of the cosmos when it was young. It is bitterly cold, this ancient glow, only a few degrees above absolute zero, the chilliest pervasive warmth there is. And yet a black hole as massive as the sun is colder still. It is colder than the oldest light in existence, colder than the faint radiance that fills all of space, one of the very few things in the universe that can outchill the afterglow of creation itself. There is a soft consequence folded into that coldness, and it is one of the most peaceful facts of all. Because a star-sized black hole is colder than the sky around it, it is not in this age of the universe losing warmth at all. The faint background glow that fills space is warmer than the black hole, and so, ever so slowly, the black hole drinks that warmth in rather than giving its own away. It grows by the barest trace instead of shrinking. The great evaporation, the long fading, cannot even begin until the universe itself has cooled further, dimming over unthinkable ages until at last it falls below the black hole's own faint warmth. For now, these dark spheres simply rest, taking in the soft light of the cosmos, waiting for a colder night that lies far beyond all present time. The rule that sets all this is beautifully, surprisingly upside down, and it is the kind of thing the mind enjoys turning over in the dark. You might expect the biggest, heaviest black holes to be the hottest, the way a larger fire burns fiercer. The truth runs exactly the other way. The more massive a black hole, the colder it is. The smaller and lighter it is, the hotter it grows. Heat and heft move in opposite directions here, bound together by a single clean relationship at the centre of the whole idea. A giant black hole is a frozen thing, colder than the void. A tiny one would be fierce and bright. Size and warmth are mirror images, and the smallest holes are the warmest of all. So imagine then a black hole far smaller than any star, and feel how the rule turns its warmth upward. A black hole with the mass of a mountain, squeezed into a space smaller than a single atom, would not be cold at all but genuinely hot, glowing far more brightly than its stellar cousins, pouring out radiation at a real and noticeable rate. Shrink it further still, and it grows hotter yet, its faint exhalation swelling toward a true and steady shine. The smallest black holes the universe might hold would be the brightest, fiercest sparks of this strange light, warm where the giants are frozen. It is a clean inversion of all expectation, the little ones burning while the great ones rest in cold and dark. This means the largest black holes of all are the coldest objects that exist anywhere. Deep in the core of nearly every great galaxy sits a black hole of staggering mass, millions or billions of times heavier than the sun, and by this upside-down rule, such monsters are colder than anything else in all of nature. Their temperatures sink to almost nothing, fractions upon fractions of a degree above the absolute floor, far colder even than the chilly afterglow of creation, far colder than the most frozen cloud of gas drifting between the stars. The most massive things the universe builds are also its most perfectly cold, vast frozen anchors at the centres of galaxies, glowing with a warmth so faint it scarcely deserves the name, and the giants are colder than the cold of empty space by a wide and silent margin. The deep void between galaxies hovers just above absolute zero, kept barely warm by that ancient background light, ranking among the coldest places anywhere in nature. Yet the great black hole at the centre of a galaxy is colder still, its temperature a tiny sliver of even that thin warmth. Picture the most frigid emptiness you can, the dark gulf between island universes where almost nothing stirs, and then know that the black holes brooding within those galaxies are colder than the gulf itself. They are the deep freeze hearts of the cosmos, the coldest still points around which whole galaxies turn. Hold these two extremes together for a moment, the frozen giant and the fiery speck, and feel how wide a span this single idea covers. The largest black holes are colder than the emptier space. The smallest would burn hotter than a furnace. Between them stretches an enormous range of warmth, all flowing from one clean rule about mass and temperature, all woven from the same faint glow at the edge of darkness. It is a strange and lovely symmetry, the cosmos arranging its darkest objects along a scale from bitter cold to fierce fire, with the heavy ones resting frozen and the light ones shining bright. One law, one glow, stretched across the whole vast register of what a black hole can be. The radiance itself, where it is strong enough to picture, comes in colours the size of the hole that makes it. The light any warm thing gives off has a characteristic wavelength tied to its temperature, and, for a black hole, that wavelength turns out to be comparable to the size of the black hole itself. A small, hot black hole no bigger than an atom would glow in short, energetic light. A vast, cold one would breathe out waves so long and so low they stretch across distances larger than the hole that birthed them. The light and the source are scaled to one another, the glow forever matched in size to the shadow it escapes. It is a tidy and beautiful correspondence, the radiance always cut to fit the thing that gives it. There is a kind of music hidden in that scaling, a way the mind can hear it as well as see it. Long waves are low notes, deep and slow, short waves are high and bright. So a great cold black hole sings, if you can imagine such a thing, in the lowest possible register, a tone so deep and so faint it spreads across space itself, while a tiny hot one would ring high and clear. Each black hole has its own pitch, set by nothing but its size, a single sustained note breathed endlessly into the dark. The largest ones hum at the very bottom of the scale, a bass so low no ear could follow it, threading through the night beneath everything else, a sound you would feel rather than hear, if you could feel it at all. All of this faint radiance carries energy away, and so, grain by grain, a black hole must slowly grow lighter. Every particle that drifts off from the horizon takes with it the tiniest sliver of the black hole's mass, the way a slowly evaporating pool gives up its water one molecule at a time into the air. The hole does not notice. The loss is far too small and far too slow for any single moment to register. But the direction is set. Over time, if no new matter falls in and the sky grows cold enough, a black hole will shed its mass into light, shrinking by imperceptible degrees, returning itself to the universe as a long, faint exhalation of warmth. The darkness is not permanent, it is very gradually giving itself away. And here the upside-down rule turns the fading into something almost tender to imagine. As a black hole loses mass and grows smaller, it also grows warmer, and as it grows warmer it glows more brightly, and so it loses mass a little faster still. The shrinking feeds the warmth, and the warmth feeds the shrinking very gently at first, across spans of time beyond all imagining. For nearly the whole of its life, this quickening is so slow as to be no quickening at all. a fading you could watch for the entire age of the universe and see nothing change. Only at the very end, after almost endless patience, does the process finally gather pace, the black hole warming and brightening toward its last soft moment. The fading is mostly stillness, and the stillness lasts almost forever. How long that almost forever is can scarcely be set down in ordinary words. For a black hole born from a dying star, the time it would take to fully evaporate, to shed every last trace of its mass into faint warmth, runs to something near 10 million trillion years. The number has so many zeros that to write it out would fill a line longer than the sentence holding it. Set against it, the present age of the universe, near 14 billion years, is less than the blink of an eye as to a human life, less than a single grain against a whole desert of time. These dark spheres are patient past all telling, fading so slowly that the cosmos as it now stands has not aged even the smallest measurable step along their road. The greatest black holes wait longer still, on a timescale that makes even that vast number look small. A truly enormous black hole, billions of times the mass of the Sun, the kind that anchors the largest galaxies, would take perhaps 10 to the 100th power years to fade away, a 1 followed by 100 zeros, a span so long it has its own name among those who think about the far future. By the time such a hole finally dimmed to nothing, the stars would all have died ages before, the galaxies would have scattered and gone dark, and the universe would be a cold and all but empty stillness. And there, in that profound and distant quiet, the last great black holes would still be slowly glowing, the final warm embers in an ocean of dark, taking their unhurried leave across spans of time no living thing could ever follow. To feel the size of these spans, set them against the things you know, though even that comparison soon slips past holding. If the entire present age of the universe, all 14 billion years of it, was squeezed into a single second, then the lifetime of a star-born black hole would still run for spans beyond any clock the mind can build, second after second stacked into eternities. The numbers are not large in the way a great distance is large. They are large in a way the imagination simply cannot enter, a bigness that asks only to be set down and left alone. And there is a deep peace in that, in knowing that some processes are so slow, so endlessly patient, that they make even the age of everything feel like a single quiet heartbeat. The very end of the story, when at last it comes, is the softest possible kind of ending. After all those uncountable years of slow fading, a black hole finally dwindles to its last small mass, and in that closing moment it grows briefly warm and bright, releasing the last of itself in a final flicker of light. It is sometimes called an explosion, but set against the eternities that came before, it is more like the gentlest of partings, a last soft flare and then stillness, the way a long-burning ember gives a final glow and goes out. There is no wreckage, no violence to fear, only a black hole completing its long return to the light, handing back the last of its warmth and quietly ceasing to be. The deepest dark in the universe ends not with a roar, but with a whisper, a small bright sigh into the night. What comes after that last flicker is simply space, smooth and unmarked, as if the darkness had never been. Where a black hole once brooded, there is left only ordinary emptiness, the faint trembling vacuum and the long waves of radiation drifting outward, carrying away the memory of all that mass as warmth. Nothing remains to mark the spot, no scar, no hollow, no shadow. The whole has given itself entirely back to the cosmos, dissolved into a tide of soft light spreading forever outward through the dark. It is among the most complete of all returns, an object that was once a perfect trap, unwound at last into nothing but gentle radiance, scattered so wide and so thin that it becomes, in the end, indistinguishable from the quiet of space itself. Long before any of that, in the universe's first moments, the cosmos may have made black holes far smaller than any star, and a few of them might be reaching their endings now. In the searing density just after the beginning, when all of space was packed unimaginably tight, tiny regions could have collapsed into black holes no heavier than a mountain or an asteroid, far too small ever to form from a dying star. These primordial sparks of darkness, if they exist, would be hot and would have been fading all along, and a few born with just the right small mass would be flickering out around this very moment in cosmic history. Somewhere out in the dark, perhaps, an ancient speck of shadow older than the stars is breathing its final warmth into the night, a last ember that began before the first galaxy ever turned. Astronomers have patiently gone looking for those endings, listening to the sky for the soft signature of a small black hole's last light. The final fading of such a tiny primordial hole would release a brief swell of high-energy light, a faint flash that careful instruments might one day catch, a message from the universe's first instant arriving across all of time. None has yet been seen with certainty, but the search itself is a beautiful thing. Telescopes turn to the dark, waiting with infinite patience for the closing note of a story 13 billion years in the telling. Each night the watching goes on, the great eyes open to the sky, listening for the soft farewell of something born when the cosmos was newer than new. Even if not a single one is ever found, their possible silence tells the watchers something, and the listening is never wasted. The fact that the sky is not lit with such flashes places firm limits on how many tiny black holes the early universe could have made, turning an absence into knowledge. In this way, the looking teaches even when it finds nothing, the empty dark itself becoming a kind of answer. There is something restful in that, in a search whose silence is as meaningful as any discovery. The universe replying not with a flash, but with a stillness that speaks just as clearly to those patient enough to read it. The single idea behind all of this reaches across three great realms of physics and ties them together, and that unity is part of why it is so beloved. To even speak of a black hole's warmth, Hawking had to bring together three ways of understanding the world that had long stood apart: the physics of gravity and curved space, the physics of the very small and its trembling vacuum, and the old deep science of heat and warmth and how it flows. Each had ruled its own domain, rarely meeting the others. In the faint shine that lifts from a horizon, all three came together at once, three separate descriptions of reality folding into a single shimmering result. It is one of the rare places where the great theories meet and agree, a rare handshake across the whole of physics. Of those three, the oldest is the science of heat, the patient study of how warmth moves and spreads, and it is the most surprising guest at the meeting. The laws of heat were first worked out by people watching steam engines and kettles, the homeliest of things, charting how warmth always slides from the hot toward the cool, the way energy spreads thin and never gathers itself back. No one expected those humble rules, born in workshops and laboratories, to have anything to say about black holes brooding in deep space. Yet they fit perfectly. A black hole, it turned out, obeys the same laws of warmth as a cooling cup of tea, the same deep principles governing the darkest object in the cosmos and the simplest pleasures of an ordinary evening. The cosmic and the homely, it seems, keep the same deep rules. Before any of this glow was understood, there was a younger physicist who looked at black holes and felt that they must somehow carry a hidden disorder. His name was Jacob Bekenstein, and a couple of years before Hawking's discovery, he made a daring guess that a black hole must possess what scientists call entropy, a measure of hidden disorder, of all the countless tiny ways its insides could be arranged. It seemed almost a strange thing to claim of so smooth and featureless an object. But Bekenstein reasoned that without it, anyone could simply drop a warm thing past the horizon and erase its disorder from the universe, breaking one of the deepest laws of nature, and so he insisted the hidden complexity must be there, sealed inside the dark. His idea pointed to something extraordinary about where that hidden disorder lives, and it remains one of the most beautiful results in all of science. Bekenstein found that a black hole's entropy, its measure of hidden disorder, is set not by its volume, not by how much space it fills, but by the area of its horizon, the size of its surface. Double the surface and you double the disorder. It was a deeply strange conclusion, for in every ordinary thing disorder grows with volume, with the room inside. Yet a black hole keeps its hidden complexity on its skin, written across the two-dimensional boundary, rather than tucked into the three-dimensional depths. The surface, not the interior, holds the count of all the ways the darkness could be. At first, the keeper of black holes himself doubted this, and the way the doubt turned to belief is part of what makes the story so human. Hawking, who knew black holes as well as anyone alive, initially resisted Bekenstein's claim, for if a black hole truly had a temperature and a warmth, then it would have to glow, and everyone knew that black holes could not glow. The idea seemed to lead somewhere impossible, so Hawking set out in part to show that the younger man was wrong, and in the working of it the mathematics turned beneath his hands and led him, against his own expectation, straight to the glow he had meant to rule out. The skeptic became the discoverer, his attempt to disprove the warmth instead revealing exactly how that warmth arises. So the two names came to be joined, fixed together in the measure of a black hole's hidden disorder. The entropy of a black hole is now called the Bekenstein-Hawking entropy, carrying both their names, the one who first dared to claim the disorder was there, and the one who, in trying to refute it, proved how the warmth that comes with it must escape. It stands as one of the most cited and cherished results in modern physics, a formula short enough to write on a single line, holding within it gravity and heat, and the quantum trembling of space all at once. Two minds, one initially at odds with the other, are bound forever in a single short equation about the warmth of the dark. The amount of hidden disorder a black hole carries is so vast that it dwarfs almost everything else, and the scale of it is a true astonishment. When a star collapses into a black hole, the disorder of the resulting hole is enormously greater than the disorder the star ever held, larger by a factor with more zeros than you could comfortably count. The black hole is not a simple empty thing after all. By this measure, it is among the most complex objects imaginable, holding more hidden arrangements than the entire star that made it, more than seems possible for so smooth a sphere. The featureless dark conceals a richness of structure beyond ordinary reckoning, a complexity hidden so completely that from outside it shows as nothing at all. In fact, by this reckoning, a black hole holds the very most disorder that any region of space its size could possibly contain. Pack any amount of matter into a given volume and you can only fit so much hidden complexity into it, before gravity pulls the whole thing into a black hole, and at that point the disorder reaches the highest value the space allows. A black hole is the fullest a region can be, the maximum of hidden arrangement that geometry permits, a kind of ceiling on how much complexity reality will let you crowd into one place. Nothing can be more crammed with hidden order than the dark sphere. It is the densest possible vault, the limit beyond which space simply will not hold anymore. This idea, that all the hidden disorder lives on the surface, led to one of the most far-reaching thoughts in all of modern physics. If everything a black hole hides is written across its two-dimensional skin rather than its three-dimensional inside, then perhaps the same holds true of much more than black holes. Some physicists came to wonder whether the whole of three-dimensional reality might, in some deep sense, be written on a distant surface, the way the full depth of a scene can be stored in the flat shimmer of a hologram. It is a thought almost too large to hold. The suggestion that the solid world around you might be, at its foundation, a kind of projection from a faraway boundary, all its depth encoded on a surface you cannot see. They gave that sweeping thought a fitting name, drawn from the shimmering images it called to mind. It came to be called the holographic principle, after the holograms whose flat surfaces store an image with all the illusion of depth. The principle suggests that the information needed to describe a volume of space can be captured entirely on its boundary. That depth itself might be a kind of beautiful appearance arising from a flatter, deeper truth. It remains one of the boldest ideas in physics, and it grew directly from that first strange fact about a black hole keeping its disorder on its skin. From a single warm rim of shadow came a hint that the whole universe might be written, somehow, on a distant and faintly glowing wall. The rules a black hole obeys mirror the laws of heat so closely that physicists arrange them into a matching set, and the symmetry of it is deeply pleasing. The old science of warmth has a handful of fundamental laws, and one by one each was found to have a perfect echo in the behaviour of black holes. There came to be 4 laws of black hole mechanics, laid out side by side with the 4 laws of heat they so resemble, each pairing a familiar rule about temperature and energy with a corresponding truth about the dark spheres. It was as though the universe had written the same poem twice, once for kettles and stars and once for black holes, the verses rhyming line for line across realms that could hardly seem more different. The very first of those laws speaks of an evenness across the whole surface of a black hole, a perfect uniformity. Just as a thing left alone will settle to a single temperature throughout, neither hotter here nor cooler there, a black hole settles so that the strength of its gravity at the horizon, the measure scientists call its surface gravity, is the same at every point across that surface. There is no warm spot, no cold spot. The pull at the edge is perfectly even all the way around. This matching of black hole surface gravity to the idea of a single steady temperature is the first of the parallels, a smooth and balanced sameness spread across the whole shadowed sphere, every part of the horizon in exact agreement with every other. Another of those laws tells of a quantity that, left to itself, only ever grows, and it is among the most reassuring patterns in nature. In the world of warmth, disorder tends always to increase. Spilled things scatter, heat spreads, and the total disorder of any closed system climbs and never falls of its own accord. The matching law for black holes says that the total area of their horizons behaves the same way, never shrinking on its own, only holding steady or growing. Drop matter into a black hole and its surface widens. Let 2 black holes merge and the new horizon is larger than the 2 before. The area, like disorder, has a direction it prefers, always forward, never back, a one-way tendency woven into the deep structure of things, and like the chill of absolute zero, a black hole's deepest cold can be approached but never fully reached. The lowest temperature there is, the absolute floor where all warmth vanishes, can be neared in a laboratory ever more closely yet never actually touched, forever just out of reach. The black holes keep a parallel rule. A black hole could in principle be made to spin so fast or hold so much charge that its surface gravity, its version of temperature, would fall all the way to nothing, and yet that final state can be approached and never attained. The perfectly cold black hole forever just beyond reach. The deepest stillness, in heat and in gravity alike, remains an edge you may draw near to but never quite arrive at, a limit held softly out of grasp. There is a deep cousin to the black hole's glow, a kindred warmth that arises not from gravity but from simple motion, and it makes the whole idea feel woven into the fabric of things. Physicists found that even far from any black hole, in perfectly empty space, an observer who simply accelerates, who speeds up steadily through the void, would feel a faint warmth all around them, a gentle thermal glow rising from the vacuum itself. Stand still, and space is cold and empty. Rush through it fast enough and it begins, ever so slightly, to feel warm. This kindred effect suggests that the warmth at a black hole's edge is not some isolated quirk, but part of a deeper truth, that the trembling vacuum will yield up warmth to anyone who moves through it, or falls toward it the right way. This kindred warmth is named for the physicist who first described it, and it gives the black hole's glow a gentler context. It is called the Unruh effect, and it tells of how the very emptiness of space can feel warm to one who accelerates through it, the cold vacuum turning faintly warm for anyone in steady motion. The warmth involved is unimaginably faint for any ordinary speed, far too slight to feel, yet it is real in the same way the black hole's glow is real, born from the same deep trembling of empty space. To know that even plain acceleration can coax a whisper of heat from the void is to feel how the black hole's radiance belongs to a wider family, the vacuum yielding its warmth to motion and to gravity alike. That same trembling vacuum, the restless froth from which all this warmth is drawn, fills every corner of existence, not just the edges of black holes. Right now, in the space of the room around you, in the gaps between the atoms of your own body, that faint quantum shimmer is forever stirring, sparks of energy appearing and vanishing too quickly to catch. It is the same restlessness that feeds a black hole's glow, the same deep liveliness woven through all of space everywhere. You're steeped in it, surrounded and filled by a vacuum that is never truly still, a soft universal trembling that asks nothing of you and goes on regardless, the same gentle fizz that lights the rim of the darkest things in the cosmos. The particle that falls inward carries a strange and subtle accounting with it, and this is the secret of how a black hole loses anything at all. When one of the twinned sparks slips across the horizon, it crosses into a place where, seen from outside, its energy counts as a loss rather than a gain, a debit rather than a credit on the black hole's books. The escaping partner floats off carrying real, positive warmth into the night. Its inward twin carries a matching shortfall down into the dark, and so the black hole's total mass dips by exactly that much. The glow does not chip the hole away from the outside like wind on a cliff. It drains it slowly from within, each freed particle paired with a small inward debt that lowers the hole by a feather's weight. The darkness pays for its own light, quietly, from the inside out. Mass and light are the same currency in this exchange, two faces of a single coin, and that is what lets a black hole spend itself away. The deep equivalence that ties mass to energy, the most famous relationship in all of physics, means that a black hole's mass is simply energy held in a particular form, and energy can always change its dress. So when warmth leaves through the glow, true mass leaves with it, the whole growing lighter by precisely the energy it has shed. A black hole is, in this sense, a vast reserve of energy wearing the costume of mass, slowly changing back into the plainer clothing of light. To watch it fade is to watch mass become radiance, the heaviest thing in the cosmos translating itself, gram by gram, into the gentlest glow. The rate at which a star-sized black hole gives off this glow is so achingly slow that the mind can scarcely find a comparison small enough. Across an entire human lifetime, a black hole the mass of the sun would shed an amount of warmth so trifling that no scale could ever weigh the difference, less than the mass of a single falling mote of dust across all the years you will ever live. It is not fading in any way a watcher could witness. It is fading the way a mountain wears down beneath the once-a-century brush of a feather, only far slower still. The stillness is almost total. The change is real but so deeply unhurried that the whole seems, to any glance across any human span, to simply hang there, unchanging, in perfect and motionless rest. Because the warmth grows fiercer as the hole grows smaller, the whole lifetime of a black hole is set by its mass in a steep and beautiful way. The time a black hole takes to fade scales with a cube of its mass, which means that doubling the mass makes the lifetime not twice as long, but 8 times longer, and a hole 10 times heavier lasts 1,000 times as long. The smallest holes wink out in moments. The stellar ones brood for that vast stretch of years with its dozens of zeros. The great galactic giants endure for spans longer still by far. A small change in heft becomes an enormous change in how long the dark endures, the lightest holes racing through their lives while the heavy ones rest, almost frozen in time, for eternities upon eternities. Picture the size of one of those great horizons, and feel how the largest black holes are not cramped at all but immense and almost stately in their slow turning. The boundary of a black hole grows in step with its mass, so a hole as heavy as the sun would span only a few kilometers, the width of a small town, while the giant at the centre of a great galaxy stretches across a gulf wider than our entire solar system, its horizon larger than the orbit of the most distant planet. You could set the sun and all its worlds inside such a boundary with a room to spare. These are not tight little pits, but vast, smooth spheres, some of them broad enough to swallow the whole sweep of a planetary system, turning quietly in the dark with their faint, cold glow. The light a black hole gives off is not quite the pure, perfect glow of an ideal warm body, and the small difference is a lovely subtlety. A flawless warm object would shine in a perfectly smooth spread of colours, set only by its temperature, but a black hole's own gravity sits in the way, filtering the outgoing light, bending and turning back some of it before it can escape. What emerges is the same warm glow faintly reshaped, a little dimmer in some colours than a perfect body would be, stamped with the faint fingerprint of the gravity it climbed through. This soft filtering even carries a name among those who study it, a reminder that the glow is not only born at the horizon but shaped by the long climb out, the radiance marked forever by the steep slope it had to cross. Warmth is not the only thing a spinning black hole gives back. It also slowly sheds its spin, winding down like a top with infinite patience. A black hole that turns carries genuine rotational energy, and the same quantum trembling at its edge lets that spin leak away into the surrounding space, the whole gradually slowing across ages even as it glows. A whirling black hole will first give up much of its spin, easing towards stillness, before settling into the long, slow fade of its remaining mass. There is a graceful ordering to it, the whole calming its rotation first, smoothing toward a quieter state, the fierce spin of its youth bleeding softly away into the dark until it turns scarcely at all. A spinning black hole can even hand energy to the space around it through a quieter cousin of the glow, a kind of generous giving outward. Waves that pass close to a turning black hole in just the right way can come away carrying more energy than they brought, having borrowed a little of the hole's spin as they swung past, so that the black hole loses rotation and the waves leave brightened. It is a soft sharing, the whirling hole lending its motion to whatever passes near, slowing itself by the smallest degree with each exchange. The dark sphere, even in this, is a giver, parting with its spin to passing ripples, easing towards stillness by warming the space that brushes against it. Time itself pools and slows near the rim of the shadow, and this is among the most dreamlike of all its features. The steep gravity near the horizon stretches the passage of time, so that a clock held close to the edge ticks ever more slowly compared to one far away, the seconds lengthening as the boundary nears. To a distant watcher, anything approaching the horizon seems to slow and slow, its motion stretching out, time draining toward an endless pause at the very edge. There is something deeply restful in that image, time growing thick and slow as honey near the rim of the dark, the rushing of the clock easing toward a stillness so complete that from outside, the final approach seems never quite to finish at all. Around many a black hole hangs a perfect circle of trapped light, a ring where photons orbit endlessly, and it is one of the most elegant shapes in nature. At a certain distance outside the horizon lies a place where gravity bends the path of light into a closed loop, so that a beam of light can circle the black hole again and again. Caught in a ring it can neither fall from nor escape. This bright thin band, the photon ring, encircles the dark sphere like a halo, woven from light that is forever going around. To picture it is to see the blackness crowned with a fine, bright loop, a circle of captured starlight wheeling around the shadow, patient and unbroken, tracing the edge of the deepest dark with a thread of pure light. The glow drowns, for now, beneath the warmth of the wider sky, and there is a quiet patience in waiting for the day it will surface. A star-born black hole is so much colder than the faint background glow of the cosmos that its own light is utterly lost beneath that warmer bath, like a single candle set before the dawn. Only when the universe has cooled across unimaginable ages, dimming far below the black hole's faint temperature, will the hole's own glow finally stand out against the dark, free at last to fade in earnest. The radiance is real today, rising even now but hidden, waiting through eons for a colder sky against which it can shine. Its true season lies almost endlessly ahead, in a universe grown quiet and dim enough to let so faint a light be seen. Set the hidden complexity of a single black hole into plain numbers, and the figure is staggering past easy belief. The horizon of a black hole as heavy as the sun, were you to count the smallest units of hidden order it could hold, would carry something like 100,000 trillion of them, a number so large it dwarfs the count of every grain of sand on Earth many times over, all of it written across a surface only a few kilometers wide. The smooth, dark face conceals an ocean of hidden arrangement, a richness of possible inner states so vast that no ordinary object of any size comes remotely close. The plainest sphere in the cosmos is, by this hidden measure, the most intricately full thing the universe ever assembles. Gather all the hidden disorder in the whole observable universe, and the black holes hold nearly all of it, an overwhelming share concentrated in the dark. Of all the disorder spread across every star, every cloud of gas, every breath of radiation, in all the reaches we can see, the black holes account for the vast majority, their share dwarfing everything else combined by an enormous margin. The great supermassive holes at the centres of galaxies are the true reservoirs of the cosmos's hidden complexity, vaults holding more arrangement than all the visible matter put together. The universe keeps most of its deep accounting locked inside its darkest objects, the bright and visible cosmos a thin froth atop a hidden depth, held almost entirely within the black. There is a firm ceiling, set by this same idea, on how much hidden order can ever be packed into any region at all, and the cleanness of that limit is a kind of comfort. The reasoning behind black hole entropy gives a strict bound on the amount of disorder, or of information, that a given volume of space can possibly contain, a maximum beyond which nature simply will not go. Try to crowd more in, and gravity intervenes, gathering the whole into a black hole before the limit can be crossed. It means the universe has a built-in restraint, a firm upper edge to how much can be stored in any patch of space, a tidy law keeping the books of reality from ever overflowing. There is order even in the limits, a sense that the cosmos knows exactly how full any corner of it is allowed to be. For a long while it remained a deep puzzle why a black hole should hold any hidden order at all, since its smooth face seemed to offer nothing to count, and the eventual answer was a hard-won triumph. In ordinary things, disorder is the count of all the ways the tiny pieces inside could be arranged, but a black hole appeared to have no pieces, no inside to arrange. Then, working within a deeper theory of nature, physicists managed for the first time to count the hidden inner states of a particular kind of black hole directly, and the number they found matched the warmth-based prediction exactly. It was a moment of profound reassurance, two utterly different paths arriving at the same figure, confirming that the hidden disorder is genuinely there, made of real if deeply buried inner arrangements, just as the glow had implied all along. That successful counting drew on one of the boldest frameworks in modern physics, a theory that pictures the smallest pieces of reality as tiny vibrating threads. In this deeper view, the fundamental constituents of nature are not points, but minuscule strings, and their countless patterns of vibration give rise to all the particles and forces of the world. Within that framework, a black hole could be described as an enormous, intricate bundle of these threads, and counting the ways they could be arranged gave precisely the hidden order the warmth-based formula demanded. To find that so abstract a picture, built from vibrating threads, could reproduce the exact disorder of a black hole was a powerful sign that the framework was touching something true, the deepest theories of matter and the warmth of the dark agreeing to the last figure. The whole question of whether the dark could truly forget became for a time the subject of a famous friendly wager between physicists, and the way it resolved is a small delight. Hawking, long convinced that information might genuinely be lost when a black hole fades, made a good-humoured bet with a fellow physicist who held that the cosmos must keep every record intact. For years, the two ideas stood opposed, the wager hanging over the question like an open challenge. In time, as the evidence mounted that the information does escape after all, Hawking gracefully conceded the bet, acknowledging that the universe most likely forgets nothing. There is something deeply human in that image. Two great thinkers settling the fate of the cosmos's memory with a wager and a handshake. The dark vindicated in the end as a keeper, not a destroyer, of all it holds. The resolution of that long debate rested on a principle so deep it underpins much of physics, the deep insistence that the present always contains the past. The fundamental laws of nature are built so that, in principle, the full state of things at any moment determines all that came before and all that will follow, nothing ever truly erased, the thread of history unbroken. A fading black hole seemed to threaten that bedrock, and so its eventual vindication mattered far beyond black holes alone, reaffirming that the universe keeps faith with its own deepest rule. To know that this principle holds even at the edge of the most extreme objects in nature is to feel how firmly the cosmos is bound to remember, how unwilling reality is to let any trace of itself fall away. It is worth resting on the sheer ingenuity of how the glow was first found, for it came not from any telescope but from a marriage of theories on paper. Hawking took the equations of the quantum world, written for flat and ordinary space, and carefully recast them for the curved and bending space around a black hole, following the mathematics step by patient step into territory no one had charted. The warmth emerged from that union, an answer waiting inside the equations all along, revealed only when two great theories were finally made to speak together in the same breath. It stands as one of the purest examples of discovery by thought alone, a profound truth about the cosmos uncovered with nothing but a pencil, a deep familiarity with the laws and the patience to carry them somewhere they had never been taken. The discovery also quietly bridged the smooth, continuous world of gravity and the grainy, countable world of the quantum, hinting that space itself may have a hidden texture. That a black hole's hidden order can be counted at all, that it comes in discrete units written across the horizon, suggests that even the smooth fabric of space and time may, at the very smallest scales, be made of countable pieces, like a beach that looks seamless from afar but is grains of sand up close. The warmth of the dark became a clue that reality is not infinitely smooth, but finely grained beneath all appearances, the continuous surface of things resting on a hidden, countable foundation. It is a thought that turns the solid world faintly luminous, every smooth expanse perhaps woven, underneath, from the smallest possible threads. There is a particular peace in knowing that this entire vast structure of ideas rests on watching empty space behave near a slope, the humblest of beginnings. No exotic substance is required, no rare and violent event, only the ordinary shimmer of the empty vacuum, set against the steep curve of gravity at a horizon. From those two plain and ever-present ingredients flows the whole cascade. The warmth, the temperature, the hidden order, the slow fading, the deep questions of memory and the hints of a grainy world beneath the smooth one. It is a marvel of economy, the grandest reach of understanding growing from the quietest of starts, the cosmos revealing its deepest secrets to anyone willing to watch the empty dark closely enough beside the edge of a falling place. The same warmth ties the fate of black holes to the long, slow story of the whole universe winding down, and there is a strange tenderness in that connection. The deepest law of heat tells that disorder across the cosmos must forever increase, that the universe drifts ever toward a more spread out, more evened out state, and the slow fading of black holes is part of how that great drift completes itself. As the holes give their mass back as warmth, they help carry the whole cosmos toward its final gentle evenness, the last great reservoirs of order softening at last into spread out light. The black holes are not apart from the universe's long settling, they are among its final actors, helping the great accounting reach its close at the very end of all the ages. From this faint horizon shine arose one of the most famous puzzles in all of physics, and even the puzzle is a peaceful thing when held in the right light. If a black hole slowly turns its mass into faint, featureless warmth, and then fades entirely away, what becomes of everything that ever fell into it, all the detail and structure of the stars and matter it swallowed? The radiation that escapes seems to carry only warmth, not the rich particularity of what went in, and so it appeared troublingly that information about the universe's past might simply be lost forever when a black hole evaporates. This gentle-sounding question of whether the cosmos can ever truly forget came to be one of the deepest riddles of the age. They called it the information paradox, and for decades it sat at the heart of physics like a koan, a question turned over endlessly in the dark. The deepest laws of nature seem to insist that information is never truly destroyed, that in principle the past could always be reconstructed from the present, that nothing is ever wholly forgotten. Yet a fading black hole appeared to threaten exactly that, to erase the record of whatever it had consumed. For a long while the two ideas stood opposed, and some of the finest minds in the world spent their careers gently circling the contradiction, unable to let it go, drawn back again and again to the question of whether the universe is allowed to forget. In time, a growing belief took hold that nothing is lost after all, and the resolution is as elegant as the puzzle was deep. Most physicists now think that the information is not destroyed but is somehow carried out, written subtly into the radiation that escapes, encoded in faint correlations too delicate to read but real all the same. The fading of a black hole, in this view, does not erase the past, it slowly returns it, threading the memory of everything that fell in back out into the universe in the patient glow of its evaporation. The dark does not forget. It only takes an almost endless time to whisper back everything it once took in, releasing the record grain by grain across the long fading. A particular moment in that fading came to mark the turning point of the whole question, and it carries a quiet name. Physicists speak of the page time, the point about halfway through a black hole's life at which, if information truly escapes, the radiation must begin to carry the old memories back out into the open. Before that moment, the glow seems featureless. After it, the hidden record should start, ever so faintly, to return. The careful study of how the disorder of the escaping radiation changes over a black hole's lifetime has become one of the central clues, a way of tracing whether and when the universe gives back what it once swallowed. The long fading marked at its midpoint by this gentle hinge. Recent years brought a beautiful turn in the story, a fresh way of seeing how the memory comes home. Working through the mathematics with new tools, physicists found that deep within the description of an evaporating black hole, there appear hidden regions, sheltered pockets in the geometry that seem to hold exactly the missing information and feed it back to the escaping light. These hidden regions, sometimes called islands, restored confidence that the record is preserved, that the radiation truly does carry the past back out. It was a deep relief, a decades-old worry eased by the discovery that the universe had, all along, a gentle way of keeping its memories and returning them in the slow warmth of the fading dark. Step back from the puzzle and feel the deeper reassurance it leaves behind, the soft truth at the bottom of it all. Whatever falls into the darkness is not, in the end, erased from existence. It is only held for a very long time and then, with infinite patience, returned. The universe, it seems, does not truly lose things. It keeps a perfect and unbreakable record, written in ways too subtle to read, and gives everything back in the fullness of an almost endless time. There is a profound comfort in that, in living in a cosmos that forgets nothing, that lets nothing fall away forever, that holds even what it has swallowed and breathes it back out, eventually as warmth and light. This warm exhalation from the rim of the shadow also revealed that black holes are not eternal, and that gentle truth quietly reshaped how the cosmos is understood. Before Hawking's glow, a black hole seemed a permanent feature of reality, a thing that, once formed, would simply endure forever, growing perhaps but never diminishing. The discovery that they slowly evaporate changed that picture entirely. Black holes became mortal in their own unimaginably slow way, things with a beginning and at the far end of time an ending. Even the most absolute objects in the universe, it turned out, are passing through, born and fading like everything else, only on a timescale so vast it makes the lives of stars look like a single breath. And so the deepest dark joined the great rhythm of all things, the universal turning of birth and fading that touches everything. A star is born, shines, and dies. A black hole forms, broods through ages beyond counting, and at last gives itself back to the light. Nothing, it seems, is exempt from this gentle cycle, not even the objects once thought most permanent of all. To know that black holes too take part in the slow turning, that they too arrive and eventually depart, is to feel how thoroughly the universe is woven from change, how even its stillest and darkest corners are, on the longest timescales, quietly in motion, coming and going like everything that has ever been. The glow is so faint that no instrument yet built has ever directly caught it from a real black hole, and that gentle elusiveness is part of its mystery. For a black hole made from a star, the radiation is so unimaginably weak, so deeply buried beneath the warmth of the sky, that detecting it lies far beyond any technology that exists or is even imagined. The glow is real in the mathematics, woven into the deepest theories, yet it has never once been seen escaping an actual black hole in the sky. It remains for now a truth known through reason rather than sight, a radiance certain in principle and still entirely hidden in practice, waiting somewhere out in the dark beyond all present reach. Yet the same warmth has been gently glimpsed in the laboratory, drawn from humbler things that share the black hole's deep mathematics. Physicists have built small systems on a tabletop, flowing water or trapped light or streams of cold atoms, arranged so that they carry a kind of artificial horizon, a place past which waves cannot return, mimicking the geometry of a black hole. And in some of these careful experiments, a faint glow has appeared at the artificial edge, behaving just as Hawking's mathematics predicts. It is not a true black hole, only an echo of one, yet the warmth it gives is the same warmth in miniature. A whisper of the real thing coaxed gently into being on a bench in a quiet room, proof that the idea holds even where no star ever died. These tabletop echoes are sometimes called analog black holes, gentle stand-ins for the real and distant thing. A smooth flow of water with a fast-moving region can trap ripples just as a black hole traps light. The ripples unable to swim back upstream past a certain point, and at that watery horizon the same faint glow of waves appears. To watch Hawking's radiation rise from a stream of water or a thread of light is to see one of the cosmos's deepest secrets rehearsed in the smallest of theatres, the physics of the darkest objects in space playing out in a tank or a fibre, the grandest scales and the smallest once more keeping the same quiet rules. The mathematics behind all of it carries a striking simplicity, a clean elegance the mind enjoys for its own sake. The temperature of a black hole is set by a single short formula, gathering together a few of nature's most fundamental constants, the numbers that govern gravity and light, and the quantum world and the flow of heat, all multiplied into one tidy expression. Into that one small line are folded the deepest features of reality, the speed of light, the strength of gravity, the grain of the quantum, the measure of warmth, all meeting in a single number for the heat of the dark. There is a quiet beauty in such compression, in so much of the universe distilled into a formula brief enough to hold in a single thought. That one formula is treasured partly because it brings together constants from realms that rarely meet, and their gathering is a kind of wonder in itself. Each of those fundamental numbers belongs to a different corner of physics. One rules the very fast, another the very small, another the pull of gravity, another the flow of warmth. They almost never appear together in a single expression, each keeping to its own domain. Yet in the temperature of a black hole, All of them meet at once side by side in one short line, as though the dark sphere were the one place in nature where every great theory was required to speak together. Physicists prize such meetings, for they often mark the spots where the deepest truths are hiding. Some have called that little formula one of the most beautiful in all of science, and it is easy to feel why when you hold it in mind. It is short enough to remember, deep enough to have launched decades of thought, and it binds together ideas that once seemed worlds apart into a single quiet statement about the warmth of the darkest things in the cosmos. To those who study such matters, it has the elegance of a perfect line of verse, every symbol earning its place, nothing wasted, the whole of it pointing toward truths far larger than itself. There is a particular pleasure in a formula like that, a sense of glimpsing, in a handful of symbols, the deep orderliness of the world. The discovery reshaped how black holes are understood so completely that it nearly redefined what they are. Before, a black hole was a place of pure gravity, a region of bent space and nothing more, a feature of geometry alone. After, it became a thermal object, a thing with warmth and disorder and a slow fading, a member of the great family of everything that has a temperature. The shift was profound. The darkest objects in the universe were welcomed into the science of heat, no longer mere holes in space but warm bodies in their own right, glowing faintly, slowly cooling, obeying the same deep laws as stars and embers and the cup cooling at your bedside. This single piece of work is widely held to be among the most important in all of physics, and its quiet weight has only grown with the years. It opened doors that remain open still, posed questions that the finest minds continue to explore, and pointed toward a deeper theory that would unite gravity with the quantum world at last. Much of the most ambitious thinking in modern physics traces its roots back to that faint horizon warmth, to the moment when someone first realized that black holes are warm. From that one soft discovery, whole new fields of understanding unfolded, and the unfolding goes on even now, in study rooms where the implications are still being patiently drawn out. Hawking himself once remarked that the discovery surprised him more than almost anything else in his work, and there is something endearing in that astonishment. He had not gone looking for a glow. The mathematics had simply led him there, against his own expectation, the way a path through a wood sometimes opens onto a clearing no map had shown. He spoke of it afterward with a kind of wonder, as one who had stumbled upon something the universe had been keeping quietly to itself. That a discoverer could be so genuinely surprised by his own discovery is a gentle reminder that even the greatest understanding often arrives unbidden, the truth revealing itself in its own time to those patient enough to follow the mathematics where it leads. The faint glow also offered the first real bridge between two great theories that had long refused to meet, and that bridging is perhaps its deepest gift. On one side stood the physics of gravity, the science of stars and space, and the bending of the cosmos. On the other, the physics of the very small, the science of particles and probabilities. For decades the two had stood apart, each magnificent in its own domain, neither quite able to speak the other's language. Hawking's radiation was one of the first places where both were needed at once, where gravity and the quantum had to work together to give a single answer. It became a precious clue, a rare spot where the two great theories touch, pointing toward a deeper unity still to be found. That deeper unity has a name, a theory long sought and not yet fully found, and the search for it is one of the great quiet adventures of the mind. Physicists dream of a theory of quantum gravity, a single description that would join the physics of the very large and the very small into one seamless whole, and the warm rim of a black hole is one of the brightest lamps they carry into that search. It shows, in a single concrete case, exactly how gravity and the quantum must cooperate, offering a precious test for any deeper theory that hopes to unite them. The faint warmth of the dark has become a touchstone, a thing any future understanding must be able to explain, a low, steady lamp guiding the long way toward a more complete picture of reality. The whole astonishing result rests on a humble starting point, a thought experiment quiet enough to hold in a single calm breath. It begins with nothing more than empty space and its faint quantum trembling, the same restless vacuum that fills all of existence, set beside the steep gravity at a black hole's edge. From those two simple ingredients, the trembling void and the bending of space, the entire cascade of consequences follows: the warmth, the slow fading, the hidden disorder, the deep questions about memory and loss. It is a marvel of how much can grow from how little, an entire new understanding of the cosmos unfolding from the meeting of empty space and a single dark sphere, the largest truths flowering from the smallest and gentlest of beginnings. It is worth resting, too, on how thoroughly this glow softened the old fear of black holes, turning a thing of dread into a thing of strange beauty. For a long time, the dark spheres were imagined as monsters, hungry mouths that devoured all and gave nothing back, the most frightening objects the imagination could conjure. Hawking's discovery softly overturned that image. A black hole, it turned out, is not a perfect devourer at all, but a slow and tender giver, breathing its mass back into the universe as warmth, returning everything in the fullness of time. The monster became a candle, the trap became a fountain, the most fearsome object in the cosmos revealed instead as one of its most patient and generous, slowly handing back all it had ever held. For the very largest black holes, the crossing of the horizon would not even be felt, and a deep calm waits inside that smoothness. The pull that would tear a small black hole's visitor apart grows weaker, not stronger, as the hole grows larger, so that at the boundary of a truly enormous one, the stretching forces fade to almost nothing. A traveller drifting across the horizon of a supermassive black hole would notice no wall, no shock, no violence at all, only ordinary space slipping by, the great boundary passing as smoothly as a thought. The most colossal black holes are also the most serene at their edges, their horizons a frontier you could cross without a tremor, the dark welcoming rather than rending, smooth all the way down. The boundary between a black hole warming and a black hole cooling falls at a particular mass, and there is a tidy precision in where that line lies. A black hole light enough to be hotter than the background glow of the sky will lose more warmth than it drinks in and begin to fade. One heavy enough to be colder will gain more than it loses and slowly grow. That dividing weight sits somewhere near the mass of a modest asteroid or a small moon, the exact place where giving and receiving come into perfect balance. Above it, the dark spheres feed and swell. Below it, they shine and shrink. The whole vast family of black holes is sorted by this one clean threshold, the heavy ones still gathering, the light ones already returning themselves to the night. The final flash, when a tiny black hole reaches its last moment, would shine across a whole spread of colours at once, a brief white blaze of every kind of light. As the hole shrinks to its smallest, its warmth climbs without limit, and in its closing instant it pours out radiation across the entire range of the spectrum, from the longest waves to the most energetic, all together in one short burst. It is the brightest the object will ever be, and the shortest lived, a single clean flare of pure warmth, and then stillness. For all the talk of explosions, the energy released is modest beside a true cosmic event, less than many an ordinary burst the sky already makes, a small bright full stop at the end of an almost endless sentence. Set the fading of a black hole beside the melting of ice, and the comparison gentles the whole idea into something you already know. A cube of ice left in a warm room gives itself up to the air across an afternoon, its sharp edges softening, its mass passing invisibly into the room as it goes. A black hole does very nearly the same, only across spans of time so vast that an afternoon could not begin to hold them, its mass passing into the surrounding dark as warmth, its edges softening across eternities rather than hours. The process is the same in spirit, a solid thing dissolving into its surroundings. Only the clock is changed. the melting stretched from an afternoon to a length of time the universe itself has not yet lived a fraction of. The relationship between a black hole's surface and its hidden order is so exact that it can be set down as a simple count, and the cleanness of it is a marvel. The horizon, divided into the very smallest patches of area that nature allows, holds about 1 unit of hidden order for every 4 of those tiniest tiles, a precise and unchanging ratio written across the whole boundary. Double the surface and you double the count, always in the same exact proportion, the disorder and the area locked together with the rigour of a law. There is something deeply satisfying in such precision. The hidden complexity of the darkest object in the cosmos, reduced to a tidy tiling of its surface, each smallest tile holding its measured fraction of the whole, the deepest mystery written in the plainest arithmetic. When 2 black holes spiral together and merge, the new horizon that forms is always larger than the 2 that made it, never smaller, and that one-way growth carries a deep meaning. The merging is among the most powerful events the universe knows, sending ripples through the fabric of space itself, and yet through all that fury the total surface only ever increases, the combined whole broader than its parents combined. This steady widening mirrors the deep law that disorder never falls, the area of horizons climbing in step with the disorder they hold. Even in the most violent union the cosmos can stage, the books still balance forward, the new dark sphere larger and more full of hidden order than the 2 that came before, the accounting always moving in a single direction. A black hole speaks in 2 very different voices, and it is worth holding both at once. When holes collide, they cry out in ripples of space-time, a brief loud shudder that spreads across the universe at the speed of the light, strong enough that instruments on Earth have felt the tremor. But the glow is the other voice, the soft and ceaseless one, a whisper so faint it has never been heard from any real black hole at all. The same object that can shake the whole cosmos in a moment of merging also breathes out a radiance almost beyond detecting, the loudest and the faintest of cosmic voices belonging to one dark sphere, the thunder of collision and the whisper of the slow fade. For a time it was feared that the edge of a black hole might hide a wall of fire, and the easing of that fear is itself a comfort. A knot in the deep logic of the glow seemed, for a while, to suggest that the horizon could blaze with a barrier of high energy, a so-called firewall that would scorch anything falling in. The idea troubled physicists, for it clashed with the older and calmer picture of a horizon you could cross without harm. Much careful thought has since worked to dissolve that fire, restoring the smooth and untroubled boundary most believe in, the horizon once more a calm frontier rather than a sheet of flame. The dark, it seems, keeps its edges cool after all, the feared wall of fire melting back into the serene and silent boundary it had always appeared to be. One graceful way through these puzzles holds that 2 observers may see the same event quite differently, and both be wholly right. To one who falls inward, the horizon is calm and they pass through it smoothly. To one who watches from afar, the infalling matter seems to linger at the edge, its information returning in the glow. These 2 stories sound contradictory, yet the deep principle of complementarity says that no single observer can ever catch both at once, and so neither view contradicts the other, each true within its own vantage. There is a deep wisdom in that resolution, a sense that reality can wear 2 faces that never meet to quarrel, the same dark sphere, both a smooth crossing and a warm returning, depending only on where you stand to watch. There is a strict limit on how much can ever be known or stored within any bounded thing, and it touches even the smallest and most familiar objects. The same reasoning that gives a black hole its hidden order sets a ceiling on the amount of information any finite region can hold, a bound named for the physicist who first conceived it. A human brain, a single book, a grain of dust, each can contain only so much, the limit set by its size and its energy, beyond which nature simply will not let more be packed in. It is a humbling and steadying thought that even the richest object has a finite fullness, a fixed maximum to all it can hold, the cosmos drawing a clean and definite edge around the contents of everything that exists. At the very end of a black hole's fading, there is a question of whether something small might remain, a last unfading ember, and the possibility has a curious charm. Some thinkers suspect that a hole might not vanish utterly, but could leave behind a tiny remnant, a speck near the smallest mass nature allows, holding within it whatever could not otherwise escape. Such a remnant would be unimaginably small, a grain at the very limit of what mass can be, sitting cold and still where a great dark sphere once brooded. Whether they exist remains unknown, but the image is a peaceful one, the long fading ending not in pure nothing but in a single small seed, a last small keeper of the dark's long memory resting in the empty dark. The cosmos as a whole may have a faint warmth of its own, a glow kin to the black holes, born from the farthest edge of all we can see. Because the universe is expanding, there is a distant boundary beyond which light can never reach us, a horizon of sorts surrounding everything, and by the same deep logic that warms a black hole's edge, this cosmic horizon should give off the faintest possible glow. It is a warmth so slight it lies almost infinitely below anything that could be felt, a temperature near the very floor of cold, and yet by the mathematics it is there, the whole sky breathing the faintest imaginable radiance inward from its farthest rim. You rest, then, not only within the glow of distant black holes, but within a fainter glow of the universe itself, bathed in a warmth that leaks from the edge of all things. This cosmic warmth means that the expanding universe behaves, in a small way, like the inside of a vast and calm black hole turned outward. The same kind of horizon, the same kind of faint thermal glow, the same deep marriage of gravity and the quantum trembling, all appear at the largest scale of all, written across the boundary of the visible cosmos. To understand the warmth of a black hole is, in part, to understand the warmth of the whole universe, the two lit by one principle, the small dark sphere and the great bright everything obeying the same single rule. There is a profound unity in that, the edge of the deepest pit and the edge of all creation glowing by the same law, the cosmos rhyming with its own darkest objects at every scale. Some suspect the early universe sowed countless tiny black holes that might still drift among us, quietly making up part of the unseen matter of the cosmos. The mysterious stuff that outweighs all the visible stars and whose nature is still unknown might, in part, be these primordial specks of darkness, scattered through the galaxies, betraying themselves only by their gravity. If so, then the dark matter that shapes the turning of galaxies could include a multitude of ancient black holes, each one faintly glowing, each one slowly fading, woven invisibly through the structure of everything. It is a striking thought that the hidden scaffolding of the cosmos might be threaded with these faint evaporating embers, the unseen weight of the universe glowing faintly all along, too dim for any eye to catch. The glow treats every kind of particle alike, giving back not only light but, where it is warm enough, the full variety of nature's pieces. A black hole warm enough will radiate not just the particles of light, but matter of every sort, every kind of tiny piece the universe contains, all pouring out in proportion set only by the hole's temperature. It does not favour one ingredient over another. Given enough warmth, it returns the whole catalogue of nature, scattering back into the cosmos a fair sampling of everything that exists. There is a kind of impartial generosity in that, the dark sphere handing back not a narrow stream but the full richness of matter and light together, returning the universe's ingredients evenly to the night. The lifetime of a black hole, set against the work of writing out its years, defeats any patience the body could bring. Imagine trying to write the number of years a great black hole will last, placing a single digit on every atom in all the earth, and you would run out of atoms long before you ran out of zeros to write. The spans involved are not merely long, they exceed the resources of the whole planet merely to record them, numbers so vast that the counting of them outstrips the counting of everything around you. To rest the mind against such a figure is to feel the edges of imagination soften and give way, the number too large to hold, asking only to be set down and released, like trying to count the moments of eternity and choosing instead to simply close the eyes. There is a way of seeing the whole of it in which the universe is a patient librarian, losing no book, however long the lending. Everything that falls into the dark is checked out, not destroyed, held behind the horizon for a span beyond all counting, and then, with infinite patience, returned in the slow warmth of the fade. No volume is ever truly lost from the great collection. The record is only borrowed, kept perfectly, and given back at last. To live in such a cosmos is to live among careful keeping rather than careless loss, a universe that files away even what it swallows and breathes it patiently back, the deepest dark revealed as the most faithful of stewards, holding everything, forgetting nothing, returning all in the fullness of an endless time. Rest too on the thought that this faithful returning happens everywhere at once, across the whole breadth of the cosmos, in perfect silence. At this very moment, at the edges of countless dark spheres scattered through every galaxy, the slow accounting is underway, particle pairs flickering into being, one slipping inward, one drifting free, warmth lifting away into the night. No sound marks it, no signal, no announcement. It simply happens ceaselessly, everywhere, the universe evenly balancing its books in the dark. To know that so vast and tender a process unfolds in total silence, asking no notice and making no noise, is to feel held within a cosmos forever at its patient work. The great slow keeping going on all around you while you rest. The mathematics that first described a black hole was written in the middle of a war, on a soldier's field desk, and there is something moving in that beginning. Within a year of the new theory of gravity appearing, a physicist serving at the front during the First World War worked out the first exact solution, describing the space around a perfectly round mass, sending his pages back from the trenches before illness took his life. That early solution holds within it the seed of everything that followed, the horizon, the warmth, the whole long story, first traced by a tired hand under difficult skies. The deepest geometry of the dark was sketched amid hardship and noise, a clean and lasting truth set down in the least likely of places, surviving long after the guns fell silent. For decades after that solution appeared, almost no one believed such objects could be real, and the slowness of that acceptance is its own kind of lesson. The idea of a region from which light could not escape seemed too strange, a mere curiosity of the equations rather than a thing the universe would actually build. Only across many years did the evidence gather, until black holes moved from mathematical oddity to accepted fact, found at the hearts of galaxies and in the wreckage of dying stars. The warmth Hawking discovered came only after that long shift, one more surprise from objects the world had been slow to take seriously, the dark proving real and then proving, against all expectation, faintly bright. The temperatures of the famous giant black holes, the ones whose shadows have actually been photographed against rings of glowing gas, are colder than any number the everyday mind can hold. The great hole at the centre of our own galaxy, and the even vaster one whose silhouette was first captured at the heart of a distant galaxy, both carry warmth so far below zero that they amount to the tiniest conceivable flicker above the absolute floor, fractions of a degree with many zeros after the decimal point. These are the coldest individual objects ever pictured, their faint glow unimaginably fainter than the rings of fire that surround them. The bright halo blazes, the dark heart within sits at almost perfect cold, a frozen stillness ringed by light. There is a frontier where even this beautiful formula reaches the edge of what is known, and that honest limit is a kind of comfort too. As a black hole shrinks toward the very smallest size nature allows, near the scale where gravity and the quantum fully merge, the simple temperature law can no longer be trusted alone, and the final instants of evaporation pass into territory no present theory fully describes. What truly happens in that last flicker remains an open question, waiting for the deeper understanding still being sought. There is no fear in that unknown, only an invitation, a small bright edge of mystery at the very end of the story, where the current map runs out and the next discovery waits. The light that climbs out of a black hole's gravity arrives wearied by the journey, stretched and reddened by the long pull it had to escape. Any light leaving a region of strong gravity loses energy as it climbs, its waves drawn out toward longer, lower, redder tones, and the radiation from a black hole is shaped by exactly this slow toll. What reaches the distant dark is light that has paid for its freedom, cooled and lengthened by the climb, the glow arriving softened by the very gravity that nearly held it. There is a worn beauty in that, light that has laboured up a steep slope and comes out the other side gentled and low, carrying in its stretched waves the mark of the deep well it left behind. A subtle and reassuring detail of the whole picture is that the escaping radiation is born just outside the horizon, not dragged up from within. The glow does not climb out of the sealed interior, which nothing can leave. It forms in the thin shell of space just beyond the boundary, where the parted particles drift free without ever having been inside. The dark heart stays sealed. The warmth arises at its threshold, in the trembling skin of space that wraps the shadow. This means the glow breaks no rule, frees nothing from the trap, only gathers at the very lip of it, a radiance born at the doorway rather than smuggled out of the locked room within. The whole slow life of a black hole can be pictured as a single coal, cooling in an empty room across a length of time the universe has not begun to spend. A coal pulled from a fire glows, cools, dims, and finally goes dark across an evening. A black hole does the very same, only its evening is so long that a number of years with 60-odd zeros must pass before the glow winks out. The image holds at every step, a warm thing radiating into the cold around it, dimming as it gives its heat away, fading toward dark. Only the clock is changed past all comprehension, the brief life of an ember stretched into a span that dwarfs the present age of all things, the coal of the cosmos cooling with infinite patience in the dark. The energy carried by a single particle of this glow, from one of the great cold holes, is so small it nearly escapes meaning. Each photon drifting off from a supermassive black hole carries a sliver of energy so tiny that countless trillions of them together would still amount to less warmth than a single beat of a moth's wing. The glow is not faint in one place and strong in another. It is faint everywhere, made of the smallest imaginable parcels of light, each one a whisper at the very threshold of existence. To picture the radiance of a giant black hole is to picture the gentlest drizzle of the smallest possible sparks, drifting outward one by one into a dark that scarcely notices them at all. Set against the brightness of even a modest candle, the total glow of a star-sized black hole today would be lost beyond all finding. If you could somehow gather every scrap of radiation a solar mass black hole gives off in a moment and weigh its brightness, it would fall unimaginably short of the light of a single candle seen across a room, dimmer by a margin no ordinary comparison can bridge. These objects are not merely faint, they are among the dimmest warm things the universe contains, their entire output a flicker beneath the flicker of the smallest flame. The darkest objects in the cosmos are also, for now, among the very faintest lights, shining with less than the glow of a candle and yet shining all the same. A deep and surprising lesson hides in all of this, that a horizon, any horizon, seems to come with a warmth of its own. Wherever the universe draws a line past which information cannot reach an observer, whether around a black hole or around the edge of the visible cosmos or for one who simply accelerates, a faint thermal glow appears at that boundary. Warmth, it seems, is the universe's quiet answer to any horizon at all, a heat born wherever a limit on knowing is drawn. A deep harmony lives in that, the same faint glow arising at every kind of edge, as though temperature itself were woven into the very act of a boundary, the cosmos warm at all its limits. This means the warmth of the dark is not an accident of black holes alone, but a clue about the deep nature of space, time, and information together. That horizons glow, that boundaries carry heat, that hidden order is written on surfaces, all point toward a reality in which space and time and information are bound together far more tightly than anyone once supposed. The faint radiance Hawking found is a thread that, pulled gently, unravels toward the deepest questions there are about what the universe is truly made of. From so small a glow comes so large a hint, a thread of warmth leading inward toward the very foundations of things, the dark quietly pointing the way. Rest, then, in the largeness of what a single faint glow has opened. From one thread of warmth at the rim of a shadow flow temperature and disorder, the holographic idea and the counting of hidden states, the riddles of memory and the hints of a finely grained reality, the warmth of horizons everywhere, and the deepest puzzles of space and time. It is among the most generative discoveries ever made, a small soft light that has lit decades of the deepest thinking and lights it still. And all of it began with someone wondering, patiently, what empty space would do at the edge of the dark, the grandest questions in physics flowering from the quietest of glows. There is a deep equality in the glow too, a way that every black hole, large or small, shares in the same faint warmth. Each one, from the smallest primordial speck to the greatest galactic giant, carries its own temperature, its own disorder, its own slow fading, all flowing from the same single idea. The glow does not pick favourites. It touches every black hole alike, weaving them all into one family bound by a single law. Whether a hole anchors a galaxy or could rest on the head of a pin, it shines by the same principle, fades by the same rule, belongs to the same deep order. The whole vast range of black holes across every scale is gathered together under one soft and universal warmth. Picture for a moment the sheer number of these faintly glowing things scattered through the cosmos, and feel how the dark is secretly alive. There may be billions upon billions of black holes spread across the universe, one at the heart of nearly every great galaxy, and countless smaller ones drifting between the stars, and every single one of them is glowing, ever so faintly, breathing its slow warmth into the night. The whole universe, then, is softly luminous in a way no eye can see, threaded everywhere with these faint exhalations of light from its darkest objects. The cosmos you imagine as scattered with black voids is, in truth, scattered with the gentlest of glows, a dark made everywhere warm by the very things once thought most cold and empty. The radiation a black hole gives off is perfectly random, carrying no pattern, no message, only warmth, and there is a strange peacefulness in that purity. The light that escapes is thermal, the most featureless kind of glow there is, the same smooth radiance any warm body gives off simply for being warm, with no structure written into it at all. It is as plain and patternless as the warmth from a stone or the glow of an ember, a pure and uniform exhalation with nothing hidden in its surface. Whatever subtle record the fading may carry lies far beneath this smooth glow, too delicate to see. On its face the radiation is simply warmth, clean and even and smooth, the most untroubled light imaginable. Because the light is so perfectly featureless, a black hole is in one sense the simplest object in the universe, even as it hides the most, and that paradox is a lovely thing to turn over. From outside, a black hole can be described by only a few numbers: its mass, its spin, its charge, and nothing else. Two black holes with the same few numbers are utterly identical, however different the things that fell in to make them. It is the plainest of all objects on its surface, describable in a breath, and yet within, by the measure of its hidden disorder, it holds more complexity than almost anything else that exists. The simplest face in the cosmos conceals the richest depths, a smooth and featureless sphere hiding an ocean of hidden order. This idea, that a black hole hides everything about what fell in behind only a few simple numbers, was given a memorable and gentle name. Physicists say that a black hole has no hair, meaning that all the fine detail of whatever formed it is smoothed away, leaving only mass and spin and charge to describe it from outside. Whatever rich and tangled history of stars and dust and light went into its making, the finished whole shows none of it, presenting only a perfectly smooth and featureless face to the universe. The phrase has a certain charm, the dark sphere imagined as utterly bald, every wrinkle of its past combed perfectly away, its surface as smooth and plain as anything can be. Hawking's glow quietly complicated that perfect smoothness, hinting that the lost detail is not gone but only deeply hidden. If a black hole truly returns the information of what fell in, encoded in its faint radiation, then the smoothness of its face cannot be the whole story. Somewhere, in ways too subtle to read, the record of its history must be carefully kept. The bald sphere, it seems, remembers after all, holding the memory of everything it swallowed in places far below the surface, ready to release it across the long fading. The simplicity is real but not complete. The smooth face a kind of thin mask over a depth that forgets nothing, a plainness that conceals a perfect and patient memory. Think of how slowly all this unfolds, and let the sheer leisure of it ease the mind. A black hole does nothing quickly. It forms over the collapse of a star, broods for spans of time beyond all counting, fades across ages that dwarf the present life of the universe, and gives its final flicker only at the very end of an almost endless road. There is no rushing anywhere in its story, no urgency, no haste. It is the most unhurried object imaginable, taking its time on a scale that makes patience itself seem impatient. To rest your thoughts on something so vast and so leisurely is to feel your own small hurries loosen, to borrow for a moment a little of that immense and untroubled calm. The warmth that escapes spreads outward forever, thinning as it goes, joining the great tide of light that fills all of space. Once a particle of Hawking radiation drifts free of the horizon, it travels onward through the dark at the speed of light, never stopping, spreading ever wider and fainter across the cosmos. Across billions of years it crosses unimaginable distances, mingling at last with all the other light of the universe, the starlight and the ancient afterglow, becoming one more soft thread in the warmth that fills everything. The glow of the darkest object becomes, in the end, indistinguishable from the faint radiance of the whole, a private warmth given freely to the common light of all of space. There is a kind of generosity in this, a quiet giving without any asking in return, and it is among the most soothing thoughts the idea offers. A black hole pours out its warmth endlessly into the dark, expecting nothing, receiving nothing, simply glowing because that is its nature, the way a fire warms a room whether or not anyone sits beside it. It does not hoard its light or wait to be noticed. It gives, steadily and forever, across spans of time no witness could ever keep. To imagine such an object, brooding alone in the deep, shining its faint warmth out into an empty dark for ages beyond counting, is to feel something tender in the very structure of the cosmos, a generosity built into even its loneliest corners. Consider that the faint warmth lifting from the horizon is, in a sense, the universe carefully balancing its books. The deep laws of heat insist that disorder must always grow, that warmth must keep flowing and spreading, and a black hole that only ever swallowed and never gave back would silently break that rule. The glow sets it right. By shining, by slowly returning its mass as warmth, a black hole keeps faith with the oldest accounting in nature, ensuring that the great ledger of disorder always climbs, never falls. The radiation is, in this light, a kind of cosmic bookkeeping, the universe quietly making sure that even its darkest objects pay their warmth back into the whole, that the long sums of heat and disorder always come out right. This bookkeeping reaches across the deepest laws, tying the warmth of the dark to the fundamental honesty of the cosmos. Without the glow, The dark spheres would offer a way to make warmth simply disappear from the ledger of the cosmos, breaking the deep principle that disorder never decreases, opening a loophole in one of nature's firmest rules. Hawking's radiation closes that loophole completely. With the glow in place, the books always balance. The disorder of the whole universe always rises. The deep law holds without exception even in the presence of the darkest things. There is a deep integrity in that, a sense of a cosmos that does not cheat, that keeps its deepest promises even at the edge of its most extreme objects, the warmth of the dark standing guard over the honesty of the whole. It is worth pausing on how the smallest scales and the largest meet in this one idea, the very tiny shaping the very vast. The glow is born from the smallest events imaginable, the fleeting flicker of particle pairs at the quantum scale, the barest tremor of empty space. Yet its consequences unfold across the largest stages there are, the slow fading of black holes across spans of time longer than the present age of everything. The tiniest cause yields the grandest effect, a whisper of quantum trembling at the horizon, adding up, across eternities, to the complete dissolution of the most massive objects in the cosmos. The very small and the very large clasp hands in the warmth of the dark, the least event in nature shaping the longest story it can tell. Rest a while in the thought of just how mild this whole process truly is, for there is nothing in it to disturb the mind. The long evaporation is not a catastrophe, but the faintest of warm exhalations, a heat so slight and a pace so leisurely that across the entire life of the universe it has scarcely begun. There is no violence in it, no rupture, no sudden end, only a long, tender giving back, an object easing itself into light over reaches of time past all feeling. Of all the great processes in the cosmos, few are as peaceful as this, the warm, slow loosening of the dark, a thing so mild it could lull the universe itself toward rest. Picture a single black hole somewhere far out in the deep, brooding alone against the stars, and let its stillness keep you company. No light reaches it from any nearby sun. No eye has ever found it. It simply hangs there in the dark, a sphere of perfect shadow, glowing with a warmth too faint to see. Around it, space is silent and cold and almost empty, the stars scattered thin and distant, and still the black hole shines, breathing its slow radiation into the night, keeping its long and patient vigil with no one to witness it. There is a deep stillness in that image, a solitude that is not lonely but serene, a dark thing faintly warm in the hush of the deep. Now widen the view to a galaxy entire, with its great central black hole resting at the very heart, and feel the calm that sits at the centre of all that turning. Around it, hundreds of billions of stars wheel in their slow orbits, the whole vast spiral turning across hundreds of millions of years, and at the still point of it all broods the cold black hole glowing faintly, anchoring the dance. Everything moves around it. It moves least of all, the steady centre of an immense and turning world. There is a profound peace in that arrangement, the frozen, faintly glowing heart at the core of all the motion, the still point on which a whole galaxy slowly turns. The largest black holes are so cold that their faint warmth is among the most delicate things in all of nature, almost too subtle to be real. The temperature of a giant galactic black hole is so close to the absolute floor of cold that it can hardly be distinguished from nothing at all, a warmth measured in the tiniest slivers of a degree, a glow so faint it borders on pure stillness. To call it warm is almost a kindness. It is more like the memory of warmth, the faintest possible departure from perfect cold. And yet it is real, this barely there glow, a true temperature however slight, the great frozen hearts of galaxies shining with a radiance so delicate it seems to hover at the very edge of existence. Compare that delicacy to the searing speck a tiny black hole would be, and feel the whole sweep of the scale once more. Where the giant is colder than the void and glows almost not at all, the smallest black hole would be fierce and bright, hot enough to pour out radiation in a steady blaze, fading fast in its fierce warmth. The same single law that leaves the great ones frozen makes the little ones burn, the temperature climbing without limit as the size shrinks toward nothing. From a glow too faint to feel to a heat too bright to ignore, the whole range is held in one rule: the dark spheres arranged along an enormous ladder of warmth, from the barely there to the brilliant. There is something fitting in the way the universe's most extreme objects turn out to obey its homeliest laws, and it is a thought that settles the mind. The black hole, the most exotic and forbidding thing the cosmos makes, follows the same patient rules of heat that govern a cooling cup, the same drift of warmth out of the hot and into the cool, the same slow spreading of disorder. The extraordinary bows to the ordinary. The most alien object in nature keeps the same patient accounting as the most familiar. To know that the deepest dark and the simplest evening warmth answer to one set of laws is to feel how unified the world truly is, how the same deep logic runs through all of it, from the cup at your bedside to the heart of a galaxy. The mind comes back, at the close, to the very edge of the horizon, to that thin shell of space where the whole story begins, the stillest place there is to rest. There, at the boundary of the dark, the vacuum trembles, particle pairs flicker into being, and one by one a few drift free to carry their thread of warmth into the night. It is a ceaseless, wordless activity, unfolding endlessly across the whole surface of the sphere, a faint and patient shimmer at the lip of the deepest dark. Nothing is hurried, nothing is forced. The glow simply rises, grain by grain, the way mist lifts from a still lake at dawn. To picture that thin, warm shell is to picture the gentlest engine in the cosmos, patiently turning darkness into light. Imagine the texture of that horizon, smooth beyond any smoothness you have ever touched, a surface with no roughness at all. It is not made of anything, this boundary. It is pure geometry, a line in the shape of space itself, and so it is perfectly even, without grain or seam or flaw. No surface in the ordinary world comes close to its smoothness, not polished glass, not still water, not the most flawless mirror ever made. It is smoothness in its ideal form, an edge so perfect it exists only in the mathematics, and along this flawless boundary the faint warmth rises, the gentlest glow climbing from the smoothest surface there is. The whole of this radiance flows from the simple fact that the horizon divides what can be reunited, and there is a faint poignancy in that division. The trembling pairs of particles are born together, meant to meet again and vanish as one, and almost everywhere they do. Only at the horizon are some of them parted forever, one falling in, the other set free, the boundary cutting between them before they can rejoin. It is this quiet severance, this one-way separation, that turns the silent froth of the vacuum into a steady glow. The warmth of the dark is, in a sense, the warmth of partings, of pairs divided by the edge of the shadow, each freed particle a small bright trace of a togetherness the horizon would not allow. Notice how the freed particle, drifting away into space, becomes wholly real and lasting, no longer a fleeting flicker but a true and permanent thing. Born as half of a momentary pair meant to vanish in an instant, it is instead set loose by the horizon to travel the cosmos forever, a real particle carrying real warmth out into the night. The fleeting becomes the eternal. The momentary spark, which everywhere else would wink out at once, is here granted a lasting life among the stars. There is a real wonder in that transformation, a thing born to vanish in a heartbeat, instead set free to drift for the rest of time, the edge of darkness turning the briefest of sparks into a lasting light. Consider that this slow leak of warmth means a black hole is, very gradually turning itself inside out, returning its hidden mass to the open sky. Everything a black hole is, all its vast concentrated mass, lies sealed away behind the horizon, hidden utterly from the universe. Yet through the glow, piece by piece, that hidden mass is converted into warmth and released, the sealed interior slowly leaking back out into the open as light. Across spans of time beyond counting, the whole turns its secret depths into shared radiance, the hidden becoming the given, the sealed becoming the freely scattered. It is the slowest of unveilings, a dark vault patiently emptying its treasure back into the common light of the cosmos. There is a profound humility in how long the universe is willing to wait for this, and the patience of it can still any restless thought. The cosmos does not hurry the fading of its black holes. It allows them reaches of time so wide that the present age of everything is beside them the merest flicker. There is no impatience anywhere in the process, no pressure toward completion, only an endless willingness to let the slow warmth rise across eternities. The universe, it seems, has all the time there is and spends it freely, letting its darkest objects fade at whatever unhurried pace nature sets. To rest in that thought is to feel how little anything truly needs to be rushed, how much room there is, after all, for things to take their time. Hold the strange comfort that even the end of a black hole leaves the universe richer, not poorer, for the warmth simply rejoins the whole. When a black hole finally fades, nothing is truly lost. Its mass has become light. Its hidden depths have become shared warmth. Its long shadow has dissolved into the common glow of space. The cosmos is not diminished by the ending, but quietly enriched. The dark sphere transformed into a tide of radiance spreading forever outward. There is no grief in such an ending, only a soft completion, a thing returning fully to the light from which all things came. The fading of the dark is not a loss, but a homecoming, the warmth finding its way back into the great and welcoming whole. Let yourself rest now in the largest view of all, the universe across its longest stretch of time, with the black holes as its final patient lamps. Far ahead, after the last stars have burned out and the galaxies have drifted into dark, the cosmos will be a vast and silent stillness, cold beyond imagining, almost wholly empty. And through that immense final hush, the black holes will go on glowing, the last warm things in all of creation, fading so slowly that they outlast everything else by spans beyond all counting. They will be the universe's closing embers, faint and patient lights in an endless dark, the final warmth of a cosmos settling at last toward its deepest rest. There is a tenderness in imagining the very last black hole, glowing alone at the end of time, keeping the final vigil of warmth. Long after everything else has faded, one last dark sphere will remain, breathing its slow radiation into a cosmos otherwise gone entirely still, the lone keeper of the last warmth there is. And then, at the close of an almost endless age, even it will give its final faint flicker and softly cease, the last light in all of existence winking softly out. It is the gentlest possible ending to the largest possible story, the universe falling at last into a perfect and peaceful dark, lit to the very end by the patient glow of its deepest things. But that ending lies so unimaginably far ahead that it need cast no shadow at all, and the thought of it can rest as lightly as a feather. The fading of the last black hole waits across spans of time so vast that the entire history of life, of stars, of galaxies, is less than the first instant of the journey. It is not a thing to be feared or grieved. It is simply the far, soft horizon of the longest story there is, a faraway close set so distant that it touches nothing in the warm and living present. To know it is there, waiting peacefully at the end of everything, is only to feel the deep calm of a cosmos that even in its final fading does nothing harshly, that lets even its ending be slow and warm and kind. Return, for a quiet while, to the simple and astonishing heart of the whole idea, the single fact from which all the rest unfolds. Black holes are not perfectly black, they glow. The darkest objects the universe knows how to make are, very faintly, sources of light, breathing their warmth slowly back into the night over reaches of time too long for any imagination to enter. From that one soft truth flows everything else, the temperature and the disorder, the slow fading and the deep questions, the bridge between great theories and the hint of a hidden order behind the world. It all begins with a glow at the edge of darkness, a warmth where everyone had expected only cold, a light leaking softly from the deepest well in all of creation. The wonder of it settles over you like a soft weight, the marvel that someone sitting alone with mathematics could discover the warmth of objects no one would ever directly see. Hawking did not travel to a black hole. He did not catch its glow in any telescope. He found it with thought alone, following the equations into a clearing no one had known was there, and what he found has reshaped how the cosmos is understood ever since. There is something deeply moving in that, in the power of patient reasoning to reach across the universe and uncover the secret warmth of its darkest things, the mind alone touching truths that light itself could never bring back. Feel, too, how the whole discovery turns on a kind of balance, a delicate evenness between opposites that runs all through it. Falling in and drifting free, warmth and cold, the tinier scale and the largest, gravity and the quantum, loss and return. At every turn, the story of the glow is a story of opposites held evenly together, neither one winning, both somehow true at once. The black hole both keeps and gives, both hides and reveals, both endures and fades. There is a deep equanimity in that, a sense of a cosmos balanced on the finest of edges, holding its contradictions in a calm poise and inviting the mind that contemplates it to rest in that same even balance. Let the breath grow slower still as the thought widens once more, out to the faint warmth that threads through all of space, everywhere, in the gaps between the atoms of the air, at the edges of the darkest objects in the deep. That quiet trembling of the vacuum stirs, ready to yield its whisper of warmth. The cosmos is steeped in this soft liveliness, this hidden readiness to glow, woven through every empty place from the room around you to the rim of a black hole at the far end of the universe. You rest tonight inside that same trembling, surrounded by the very stuff from which the dark draws its light, held in a vacuum that is never quite still and never quite cold. There is a final softness to gather in, the way this whole idea reassures rather than alarms, even though it speaks of black holes and endings. Every part of it, looked at closely, turns toward comfort. The darkest things are warm. The deepest traps slowly give back. The most absolute objects are, in their own slow way, impermanent and kind. The universe forgets nothing and rushes nothing and loses nothing in the end. To hold the story of Hawking's glow in a settled mind is to feel, again and again, that the cosmos is gentler than it first appears, that even its most fearsome corners hide a tenderness, a warmth, a slow and patient grace. So let the gaze rest one last time on that thin, warm shell at the edge of the dark, the place where it all begins and where the night will leave it. The vacuum trembles, a pair of sparks flickers into being, one falls inward, one drifts free, and a thread of warmth lifts away into the endless night. It is happening now, at this very moment, at the edge of countless black holes scattered through the cosmos, a soft and ceaseless glow rising from the deepest dark all across the universe. And it asks nothing of you, this gentle radiance, only that you rest beside it for a while and let its slow warmth carry you down towards sleep. Here then is the final wonder, the one to close the long night upon. For all its strangeness, for all the depth of its mathematics and the vastness of its timescales, the warmth at the edge of darkness is, at heart, a deeply peaceful thing, the gentlest possible truth about the most fearsome objects in the cosmos. It says that nothing is ever quite black, that even the deepest dark gives off a little light. It says that nothing is ever wholly lost, that the universe keeps a perfect and patient record and returns everything in the fullness of time. It promises that nothing, not even the most absolute object imaginable, lasts forever or works in haste, that all things fade slowly and gently back into the light from which they came. The black hole, once the very image of dread, becomes in the end the image of a quiet and infinite patience, a slow warm glow brooding in the deep, returning all it holds across spans of time beyond all feeling, asking nothing, keeping everything, fading so gently that the universe itself could rest to the rhythm of it. And tonight, far above you, beyond the dark and the cold and the long reaches of empty space, those faint warm glows are rising still, at the edges of 1,000,000 black holes scattered through the night, each one breathing its slow light into the dark, patient and tender and utterly at ease, while the cosmos turns quietly around them and the long, soft fading goes gently on. The journey through all of it is done now. 101 wonders of a faint light rising from the deepest dark, gathered and laid softly across the night, and now there is nothing left to do but rest. If you are still here, drifting in the warmth, another quiet journey is already waiting for you on the screen, ready whenever you might want it, or never at all. There is nothing to choose and nothing to reach for. You do not need to remember any of it. Not the numbers, not the names, not the temperatures or the timescales, or the shape of the glow. Let all of it loosen and float free, and what stayed, stayed. What slipped away was only ever passing through, and that is exactly as it should be. The glow is still rising far away, just as it was before you ever heard of it, just as it will be long after. It needs nothing from you. It only shines, faint and slow, at the edge of its waiting dark. Let the breath grow long now. Let it slow on its own. There is nowhere to go, nothing to hold. The day is behind you, and the soft warmth lifts away into the dark without any help at all. Let the shoulders soften, let the hands fall open. Far out in the deep, a thread of warmth rises softly from the rim of the shadow, and here, in the stillness, you can let go of even that. Rest now. Let the last of it drift away. And now, 101 wonders are resting with you. Sleep now. Good night.